Hello everyone, welcome back to this physics mastery, and this is lecture 4 and we are going to discuss about work, power and energy. So I hope that your preparation is going well at this point in time, and right now the best source to practice would be PYQs, and of course in PYQs also there are so many questions. It's very difficult for you to solve all the questions. That's why I have selected the best of the questions, most difficult, typical kind of questions from JEEs, and that is what we are having in this phase now. Okay, let's go on to this work for energy topic, solve some important typical PYQs here. A bead of mass M slides without friction on the wall of a vertical circular hoop. So there is no friction here. That means you can conserve energy. That's important. Hoop of radius capital R as shown in the figure. The bead moves under the combined action of gravity and massless spring attached to the bottom. So it is attached to the bottom over here. This is where it is attached to. The equilibrium length of the spring is R. Equilibrium length in the sense natural length. So when it is not stretched, unstretched length of the spring is R. If the bead is released from top of the hoop, with zero initial speed, velocity of the bead, when the length of the spring becomes R. When length of the spring becomes R, then what would be the speed of it? So length of the spring has to become R, and that will be, this is 2R right now. Elongation is R, natural length is R. And so somewhere here when the spring comes to, the block comes to, at this orientation, length of the spring is, let's say, R. Okay. So now I need to find that orientation, that particular position there. What we will do is a bit of geometry. Let's say this is the center of the hoop we have, and you just join it. And this is R because radius. This is also R. That is also radius. Now you see you are creating an equilateral triangle here. R, R, R. And that means this is going to be 60 degrees. So when the position vector of the bead makes an angle 60 degrees with vertical, that's where the length of the spring becomes R there. That's orientation. Now I want to use conservation of energy. So as it is coming down, there is a loss in gravitational potential energy and strain energy in the spring. Together it will be converted into gain in kinetic energy. So this is the basic idea here. So you see, what is the loss in spring energy? Half k r square. R was the initial deformation. Finally, deformation is 0 because it has come to natural length. And what is the loss in gravitational potential energy? For that, I need to see how much it has fallen. This h I want to calculate. You see, if you divide that into two parts, this is R, okay. And then if this is 6, right, this will be R cos 60, which is R by 2. That means R plus R by 2, it will be 3R by 2. So loss in gravitational potential energy is mg into 3R by 2. Together it has to be converted into kinetic energy. That's it. From here you need to calculate speed. So that is all simplification. You can look at it. It's a very simple geometry based question. Let's move on to the next problem there. Right. So now I'll take it to this side. A sand dropper drops sand of mass m on a conveyor belt at the rate proportional to square root of the speed, that is dm by dt is proportional to root v. If p is the power delivered to run the belt at a constant speed, then which of the following relationship is true? So a belt is being run at a constant speed and also a power delivered we need to consider. So when the belt is going with constant speed, net work done on the belt has to be 0. So here, a rate of work done by the engine. Rate of work done by the engine. Some engine would have been connected to the belt. Because of that it is running. Some motor. Rate of work done by the engine on the belt. Alright, so that much energy is being supplied. The work is basically inflow of energy. So engine is supplying energy to the belt, but belt is not changing its kinetic energy, it's having a constant speed. So this must be equal to rate of work done by the belt on the sand. Okay, so you need to understand the flow of energy. Energy is flowing from engine to the belt and from belt to the sand. So whatever is the rate of energy supplied from engine to the belt, the same energy has been supplied to the sand. So we assume that the transition is 100% there. So rate of work done by the belt on the sand, if you calculate, that is enough. And what is the rate of work done? F bar dot V bar, alright? F into velocity. Here force between the sand and the belt is basically frictional force, which is dragging it along. So anyway, velocity we have it, alright, but we need to find the force, that is going to be the power there. So how do I find force? For that I'll use kinematics idea. The force that you are getting, whatever is, whether it's frictional force or whatever it is, net force acting on it on the sand horizontally will be equal to mass of the sand part, little lump of sand you consider, it's falling in dt time, let us say. Finally it will come to v velocity, but just before dropping it has got zero velocity. Change in velocity by time interval will be acceleration. Mass into acceleration. Mass is dm, acceleration is v minus 0 divided by 2 dt. So that is going to be rearranged as dm by dt into velocity. Okay, and dm by dt he is saying that it is proportional to root v. That means root v into v, it is proportional to v power 3 by 2. If I substitute it here, you see that power will be proportional to v power 3 by 2 into v, that is going to be v power 5 by 2. Otherwise p square proportional to v power 5. So that's the answer we have it. It's a nice problem and I hope you understood that. Now let's move on to the next problem there. A body of mass 1 kg begins to move under the action of time dependent force given, where I cap, j cap are come there. Power developed by the force at the instant when t equal to 2 seconds is. Okay. So they are asking you to find the power. Power will be equal to F bar dot V bar. Okay. Force is known, but velocity is not known. To find velocity, what we do is you start from force, you calculate acceleration, which is force by mass. Once you have acceleration, integrate acceleration to get velocity, because initial velocity is 0. So the change in velocity is nothing but final velocity only. So we'll just integrate it. Mass is 1 kg only. That means acceleration equal to same t I cap plus 3t square j cap divided by m when m is 1. This you write as dv bar by dt. Alright. And then rearrange terms. You will get v bar equals to t square by 2 I cap plus t cube j cap. That is going to be velocity at any time t, assuming initial velocity is 0. Begins to move, no? That means initial velocity is 0. Okay. So now you have velocity and you have force here. So we can write this as fx into vx plus fy into vy. Alright, dot product. So fx is t into t square by 2 plus fy is 3t squared into t cube. That is going to be the power. That means you have t cube by 2 plus 3t power 5. That's the power at any instant. If you want to find the power at t equal to 2 seconds, you can substitute there. P at t equal to 2 seconds will be what? 8 by 2 is 4 plus 3 into 32. Okay, 3 into 32. How much is that? 3 2s are 6, 3 3s are 9. 96 plus 4, 100 you will have it. 100 watt. That's about it. I think it is simple only. That just finding the integration and then solving it. Let's move on to the next problem. A body of mass 2 kg is initially at rest. It starts moving unidirectionally under the influence of source of constant power. So again, it is also about power. I see that students are struggling a little bit on power calculation. That's why I'm taking more questions on power. Its displacement in 4 seconds is this much. We need to find that alpha there. Okay. So they said power equal to constant. Huh? Power equal to constant. If power is constant, then work done equal to power into time interval. Right? Integral p dt you need to do. But then p is constant, so p into time taken. But work done must be equal to change in kinetic energy. Work done must be equal to change in kinetic energy. I'm assuming the initial velocity is 0 because it's given. Rest not necessary to assume, given also. So that's what I have. Mass is 2 kg. So 2 gets cancelled. I'll get V equal to root P into root T. Root P is constant, root T is variable there. So we got velocity as a function of time. But I need the displacement. So once I have velocity, displacement is easy. You need to do integration. Okay, dx by dt equal to root P times of root T. Otherwise dx equal to root P into root T dt. So integrate, you will get the displacement here, root P equal to T power 1 by 2 integration will be T power 1 by 2 plus 1, 3 by 2 divided by 3 by 2. That means it is going to be 2 by 3 into root P into T cube. If I take it inside there, that's what I have here. Now what did they say? 1 by 3 they are talking about, and alpha is alpha square. So now you can substitute T equal to 4 seconds there. 4 seconds, if you compute right, you will get 4 cube. 4 cube is 2 power 6. 2 power 6 when it comes out, 2 power 3 you will have it. That means 2 into 8, 16 by 3 into root P. So from there you see that 16 equal to alpha square. Otherwise alpha equal to 4 you will get it. Alpha equal to 4, and it's very simple problem there. Next problem. A block is fastened to a horizontal spring. The block is pulled to a distance x equal to 10 centimeters from its equilibrium position on a frictionless surface from rest. Okay, initially from rest there. The energy of the block at x equal to 5 centimeters is 0.25 joule. Then the spring constant is. So next problem is spring problem. Spring problem also generally students ask more doubts. That's why I wanted to select some questions on spring basically. Now here, what is the meaning of this statement? Energy of the block. Energy of the block they are talking about. See, potential energy will be stored in the spring. Okay, but they are talking about energy of the block. So what is energy of the block? That's basically kinetic energy of the block. That is kinetic energy of the block. Kinetic energy of the block equal to loss in spring energy. Spring is losing energy because initially it was stretched by 10 centimeters. When it is relaxes to x, right? Relaxing to x, there is a loss in spring energy. That will be kinetic energy there. So kinetic energy equal to 0.25 joule. That's what he is saying. 0.25 joule. But what is spring energy? Spring energy, initial spring energy is half k into x naught square. Let's say this is x naught, 10 centimeter. That is initial. And what is the final spring energy? You have half k into x naught by 2 the whole square. That means it will be 1 by 4 times of initial energy. 1 by 4 times of the initial energy. Then the loss, if I talk out, loss in spring energy, it will be 1 minus 1 by 4, 3/4 of the initial energy. So 3/4 of the initial energy is 0.25. So if I substitute there, 3/4 into half k into x naught square equals to 0.25. I have it. So they are asking you to find k, right? X naught they had given. X naught is 10 centimeter. 10 centimeter is 1 by 10th of a meter. So this becomes, so 3, you can take it that way. First of all, let's write it. 3 by 8 into k into 1 by 10 square equal to 0.25. So 10 square and it goes to that side, 25. 25 into 4 is 100. Twice of it will be 200. So k will be 200 upon 3 Newton per meter. And that's going to be the answer there. So energy of the block meaning kinetic energy of the block here. That's the meaning in this context. Alright. So they gave 4 graphs here. Figure A, B, C, D. Show the variation of the force with time. And they're asking you to find the impulse. Find the graph in which of them, in which of the following impulse is maximum. That's a problem. You might try that. Impulse is maximum. So it's related to impulse equation, impulse momentum equation. Alright. What is impulse? When I ask students impulse, they say it is change in momentum. Impulse is not change in momentum. Please remember, impulse is defined for force. Integral f dt. Force into time interval is impulse. Okay. And integral FD nothing but area under the graph. You just calculate area here. J1. J1 is half of base is 1, height is 1 by 2. So you get 1 by 4. Second case, it is rectangle area. Area of the under the graph is not half. Half is the height. Base is 2. You will get 1. That is going to be J there. And then the third one. So it is basically a straight one here. Half of 0.75 meaning 3 by 4 into 1. So you get 3 by 8 here. And over here, half of base is 2, height is 1 by 2, you will get 1 by 2. So now you see, out of all, this way you will get the maximum. So answer is B. In the case of B, you will have the maximum impulse. Impulse is basically area under force time graph. Alright, next problem. A closed circular tube of average radius 15 centimeter whose inner walls are rough. Okay, so there is friction over there. Is kept in a vertical plane. A block of mass 1 kg just fits inside the tube. The speed of the block is 22 meter per second. Okay, initially 22 meter per second. Alright. When it is introduced at the top of the tube. After completing 5 oscillations, the block stops at the bottom region of the tube. Then work done by the tube on the block. So it is going to oscillate. So oscillate and oscillate, 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 and finally it will come to rest there. Because of the friction, it is losing kinetic energy continuously. Mechanical energy is continuously lost. So finally it will come to the bottom, and he is asking you to find the work done by the tube. Okay, according to physics, work is not done by you, or work is not done by me, or work is not done by the tube. When I say work done by tube, meaning work done by the force exerted by the tube. Tube will be exerting normal reaction and friction. Normal reaction doesn't work here. Just we need to calculate work done by friction basically, right? So then what do? You apply this work energy theorem. Work energy theorem. WET meaning work energy theorem. You can't use conservation of mechanical energy because kinetic friction is there. Work energy theorem says that work done by gravity plus work done by tube is equal to change in kinetic energy. Work done by tube is nothing but work done by friction. We need to calculate that only. Work done by tube equals to change in kinetic energy minus of work done by gravity. Alright. Change in kinetic energy. Initial kinetic energy is half m into 22 square. What is initial kinetic energy? Half of mass is how much? They gave us 1 into 22 square. 22 into 22. So what do I get? 11. 11 2s are 22. So 242 joule. That is initial kinetic energy. What is the final kinetic energy? 0. It will come to rest finally. So loss in kinetic energy. The initial minus final is loss. Final minus initial is change there. Okay. Work done by gravity. Work done by gravity is basically positive because it has fallen down. Finally, it is going from initial to final. So this is the displacement in vertical direction there. Finally, it will come to there. Because gravity is a conservative force, you don't have to worry about the initial point and final point. It's going to be positive. Mass is 1. G we are taking 10 into H. H is the diameter. Diameter is the 30 centimeters, 0.10. So that's going to be 3 joule. Now we can substitute there. Change in kinetic energy is 0 minus 242. That is change in kinetic energy minus work done by gravity. Work done by gravity is how much? 3 there. So you will get minus of 245 joule. That is work done by the tube. So work done by the tube meaning work done by the force exerted by the tube here. So whenever it's difficult to use conservation of energy, you go for work energy theorem, which is such much force superior. We can say it is like Brahmastra. In this energy problems, this is the best method we have. Sometimes it can be lengthy, but it's very powerful. Any problem in this particular topic can be solved using that. Okay, next. If the maximum load carried by an elevator is 1400 kg, in that 1400 kg he has given the split. 600 kg is the person's mass and 800 kg is the elevator mass, which is moving up with a uniform speed. So uniform speed they are saying, that means there is no acceleration, uniform speed. And the frictional force acting on it is 2000 newtons. There is a frictional force also we need to consider there. Then the maximum power used by the motor is, okay. So if you look at the elevator, right, there is a cable there which is pulling it up. So the motor is trying to pull it up. Power delivered by this tension is nothing but power delivered by the motor. Assuming transmission from motor to cable is 100%. Alright. Now the engine is, this particular elevator is experiencing two forces apart from tension. What is it? The total weight 1400 kg. I'm talking about maximum power, so you take maximum load 1400 kg into G. That is the weight, and also as it is moving up, because it is moving up, you will have friction also acting there. Friction is acting on the walls. That friction is also given, how much is that? 2000 Newton. So 2000 Newton is acting there. So because it is going with constant velocity, acceleration is 0. That means the tension in the cable would be the summation of this. This is 14,000 and this is 2000. You will get 16,000 Newton. That is the tension in the cable. Then power delivered by the cable equal to tension into velocity, right? Tension is upwards, velocity is also upwards. So 16,000 into velocity, they had given 3. So you will get 48 into 10 power 3 watt. So 48 kilowatt. That is going to be the power delivered by the cable which is connected to the motor there. So that's about it. Let's move on to the next problem. The ratio of power of two motors is given that are capable of raising 300 kg water in 5 minutes. This is one motor. The other motor is 50 kg water in 2 minutes. So we are dealing with two motors and we want to see the power ratio. So we need to find, of course, depth is the same. 100 meters is the depth. From 100 meters, we need to raise it. The value of x is. So power here, right? Power equal to rate of work done, right? That is equal to rate at which the potential energy of the water is raised, right? Water is going to height there. So you consider delta M mass, you are raising it to a height h. So there is a rise in gravitational potential energy. We are assuming that speed is not changing much. Even if it is there, we are neglecting it. So to raise the water from the depth of 100 meter to the surface, so there is a rise of gravitational potential energy. Let's say time interval is delta t. That is the power there. You see, in both the cases, this is same. Basically, power proportional to delta M by delta T. That means P1 by P2 will be equal to delta M1 by delta M2 into delta T2 by delta T1. Delta M1 they had given how much? 300 kg. 300 kg has been supplied, and delta M2 is 50 kg. You don't have to change the units because the ratio it will get cancelled out. Delta T2 is 2, delta T1 is 5 minutes. So you get 6 into 2 by 5. That means I'll get 12 by 5. And that's what I have here. And that is supposed to be equal to 3 root x by root x plus 1. We can compare it. So 12 equal to 3 root x if I consider, okay, 3 root x if I consider, that means root x equal to 4 or x equal to 16, alright. Same way if I check it, compare the denominator also, 5 has to be equal to root x plus 1, otherwise root x equal to 4 or x equal to 16. So both the cases it is matching out, that means x is equal to 16 is the answer there. I think comfortable only. Right, next problem. Yeah, this is one problem. I don't know, many students were asking again and again. Simple problem only, but somehow students are not able to visualize it. Let's understand that. So a ball of mass 100 grams is dropped from a height 10 centimeters on a platform fixed at the top of a vertical spring. See, the platform they are talking about, they didn't mention the mass of the platform. Mass of the platform is neglected. That's assumption here. That means the collision with the platform has no meaning there. You are colliding with a massless body. Imagine an elephant is colliding with a fly. So the elephant is not going to change its momentum or kinetic energy appreciably. You can assume it to be going with the same speed. So platform is colliding with, but there is no effect of it. So ball will hit it and then keep on compressing it. That's the idea here. The ball stays on the platform and the platform is depressed by a distance of h by 2. So after it is being compressed, it will go down to h by 2 distance further. And then it will come to rest. Again, it will go to bounce back again. It is not going to stop there. Compress, 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 go to the lowest position, and after that it will start rising up. So if the block sticks to the platform, it will oscillate actually. And if it is not sticking, it is a possibility that it might be bouncing off as well. Okay, anyway, the spring constant they are asking you to find. So first, this is the initial point I am considering, and this is the final point. Between initial and final, I want to conserve energy. I want to use conservation of mechanical energy. Right? There is a collision between platform and block, but that collision is neglected there because platform mass is neglected. So in that case, there is no loss of energy. If you look at initial stage, at initial stage, kinetic energy is 0. Finally, also kinetic energy is 0. Initially, kinetic energy is 0 because you are releasing from rest. Finally, also kinetic energy is 0 because that's the lowest point. It can't go further down. Extreme position. At extreme position, speed 0. Kinetic energy is 0. So initially kinetic energy is 0. Finally kinetic energy is 0. That means kinetic energy has not changed. But if you look at gravitational potential energy, initially it is at certain height, finally it has fallen down. So there is a loss in gravitational potential energy. There is a loss in gravitational potential energy. That will be mg into h plus h by 2. Please, h plus h by 2. It is not h. Started from there and it has gone up to there. So that is the loss in gravitational potential energy, which is 3 by 2 mgh. Kinetic energy is not changing. Then which form of energy is going to increase because of that? Gain in strain energy, gain in spring energy, and that is half k into how much is the compression in the spring? H by 2, half k h square. So loss in gravitational potential energy equal to gain in spring energy. Combining them, equating them, what do I get? mgh into 3 by 2 equals to half of k into h square by 4. So 1 2 gets cancelled here, 1 h gets cancelled out here. Then you take 4 this side, 4 3s are 12, 12 mg by h. So k equal to 12 mg divided by h. That's the answer, you have it. Okay, right, let's move on. A stone of mass m tied to the string is being whirled in a vertical circle with a uniform speed. Yeah, so uniform speed it is maintained, right? That means some external force is there acting continuously. Because of that, speed is not changing. Generally in vertical circular motion, speed changes. Bottommost point you will have the least maximum speed. At the highest point you will have minimum speed and so on. But here they are saying that speed is constant. Then the tension in the string, what will happen to it? Okay. So tension in the string we have to talk about. That means somehow they are changing the tension only. There is no other external force. Looks like that, because if external force is there, we don't know, we cannot solve it. So based on the wording, they are talking about tension only. Only possibility is that somehow with the hand you are changing the tension at various locations. You are rotating it like this, maybe you are pulling hard, slowly, or whatever it is, changing the tension. But we are assuming that only the tension is there. So initially when I write that, I thought that there is some external force also, but there is no information given about it. So we have to assume that tension is present, but tension is varying, not according to the whatever somebody else is holding it, and they are continuously changing it. Okay. So suppose, let's say this angle is theta. All right. Then this will be theta. You can resolve mg. You will have mg in this direction, mg cos theta, and in this direction mg sin theta. Alright, now mg sin theta, who is balancing? We don't know, some external force has to be there. Some external force has to be there. Tension it can balance, adjust, but that you cannot balance it. Alright, so there must be some external force, at least tangentially, if not radially. So focus on only the radial forces. What are the radial forces you have? T minus mg cos theta. And that must be equal to m into v square by r, that is L. Otherwise T equal to mv square by L, which is constant, plus mg cos theta. So here mv square by L is constant, but mg cos theta is changing here. Now when theta is least, you will have the maximum cos theta. So that means when theta equal to 0, that is the lowest point, that's where the tension will be maximum. When theta equal to 180, cos theta is least, that's where the tension will be minimum there. The same throughout the motion, minimum at the highest point of the circular path, minimum at the lowest point of the circular path, minimum when the rope is in the horizontal position. So the B is the best option. Again, there is a little bit of controversy or otherwise not much clarity here, because there must be some external force. Without that, speed cannot be made constant because tangential force is required. But external force, how do you know that only tangential component is there, not centripetal? We don't know. But if you assume centripetal force also has got some component from external part, then you cannot solve it. Okay. So certain ambiguities will come, you should be able to manage it. Okay, then let's move on to the next problem. Some questions I have taken on potential energy also, right? Potential energy is given that expression U by R, A by R power 10 minus B by R power 5, where R is the interatomic distance, A and B are positive constant, then equilibrium distance between the two atoms is. So they are talking about equilibrium distance. Equilibrium distance meaning F of R equal to 0. What is at R? At what distance R will the force be 0? That's where equilibrium happens. But they didn't give the force, they had given the potential energy. So you should know how to find force from potential energy. I hope you are aware of it. Force is equal to minus du by dr. It's one dimensional, so we can do exact differentiation only. If it is 2D, 3D, we'll do partial derivative. So F equal to minus du by dr. I hope you are aware of it. It's a very simple standard result. Minus of du by dr, you can do it, minus 10a by r power 11 minus of minus plus pi b by r power 6. This is the force and equated to 0. So you can take r power 1 by r power 6 common. You will have pi b minus 10a by r power 5 equals to 0. Then equilibrium separations are r equal to infinity, one possibility. This is left part. Otherwise, this r power 5 equal to 10a by pi b. Otherwise 2a by b. So two possibilities. R equal to 2a by b whole power 1 by 5, that is one possibility. Otherwise r equal to infinity or tending to infinity. These are the two possible values we have it. So straightforward. Next problem. A particle of mass m is moving in a circular path of constant radius r such that its centripetal acceleration is varying with time t as this. Okay, then power delivered to the particle by the force acting on it is given by. So this is the question taken from the idea of Irido problem. There is a similar kind of problem available. We need to find the power. So first of all, what is centripetal acceleration? V square by r. Alright, V square by r is given as k square r t square. So from there I will get V equal to krt or ktr. V equal to ktr. That's the velocity, you have it. Velocity we have. Then how do I find power? See, when a particle is going in a circular path, it will be experiencing two types of forces. One is the centripetal force, the other one is tangential force. Okay, and you know that velocity will be only tangential. Velocity will be only tangential. Then power delivered by centripetal force will be 0 always. Power delivered by centripetal force is always 0. That's why power is defined. So it can avoid centripetal force. The forces which are perpendicular to velocity, they cannot work. Like magnetic force cannot work. Here power centripetal force always does 0 work there. So power delivered by the force meaning only power delivered by tangential force, and that is equal to tangential force into velocity. That's it. Okay. But why need to know tangential force then? Tangential force is mass into tangential acceleration into velocity. But tangential acceleration I need to know. You should know that tangential acceleration is basically rate of change of speed, not a rate of change of velocity. Rate of change of velocity is total acceleration. Rate of change of speed. Speed we got it. KTR. So d by dt of KTR will be KR. Okay. Now everything is ready. You can substitute there. Mass into AT is KR and V is KTR, and we got the answer. So M into K into T into R square. That is the power delivered. So it's a very nice problem and conceptual problem. I hope you got it. Let's move on to the next problem. Yeah, a bullet of mass 200 gram having an initial kinetic energy 90 joule is shot inside a long swimming pool as shown in the figure. If its kinetic energy reduces to, say reduces to, they are saying, not reduces by, reduces to meaning final value is 40 joule, and they gave time. So as the bullet is shot, because of the water drag, it is slowing down. In 1 second, it is going from 90 joules to 40 joule. Then they are asking what is the minimum length of the water pole that you require so that bullet can be stopped. I think there are some movies, Hollywood movies, where you have to shoot the person inside the water. So the guy, the protagonist, puts the bullet close to the tummy and then shoots, because if there is a gap, right, because of water drag, it may slow down. So scientifically correct. Anyway, so now kinetic energy they gave. Kinetic energy formula is what? Half mv square. I need V from there. V will be equal to root over 2 ke by m. That's the velocity you have. So let's calculate initial velocity. What is initial velocity? That will be root over 2 into initial kinetic energy is 90 joule divided by mass is 0.2 kg. So you will get 900, under root will be 30 meter per second. Same with final velocity. Final velocity, that is after 1 second if you calculate, that will be 2 into 40 divided by 0.2, 400 under root will give you 20 meter per second. So we have initial velocity and we have final velocity, and also we have time duration. So I can find average retardation, average acceleration there. That average acceleration will be equal to final velocity minus initial velocity divided by time interval. You will get minus 10 meter per second square. And that is the dragging force we are having in the first 1 second. Now they are asking you to find the minimum length of the pull the bullet has to travel so that it completely comes to rest. We assume that the same average drag force is continued, average acceleration is continued, then how much time does it take to stop? It is something like you project it up, okay, with 10 meter some u velocity under gravity. Gravity is trying to slow down. Up to how much distance it can go before it comes to rest, similar to that. So anyway, we can use this formula, v squared minus u square equal to 2as. Otherwise that's equal to v square minus u square by 2a. V is 0, finally it has to come to rest. U is how much? 30 square. Starting from initially I'm taking 30 square divided by 2 into a is minus 10. So 900 by 10 will give you 90, by 2 will give you 45. 45 meters is the distance it travels completely from the beginning before it comes to rest. Okay, that much water you require. Right, next problem. If momentum of a body is increased by 20%, then its kinetic energy increases by. This is a simple problem, but still 1 or 2 students generally ask about it. That's why I've just taken it. So here, momentum they are talking about, and that is why I'll write the kinetic energy as p square by 2m. Alright, if they talk in terms of velocity, I'll write half mv square. In terms of momentum, p square by 2m. Mass is not going to change here. That means kinetic energy is proportional to p square. Okay, so ke2 by ke1 will be equal to p2 by p1 the whole square. Now momentum has increased by 20%. That means if I take initial momentum is p, final momentum will be 1.2p. Right, 20% meaning 0.2 times it has increased. Whole square, it will become 1.2 square meaning 1.44. Now I want the percentage change there. That is why you subtract 1 either side. ke2 minus ke1 minus 1 equal to 1.44 minus 1, you will get 0.44. So if you simplify it, ke2 minus ke1 by ke1 into 100 is going to be 0.44 into 100. That gives you 44%. It's a simple problem only, but still some students somehow will feel that how do you get that 0.2, right? 20% meaning 0.2 times the initial value, that idea. Okay, next problem. A stone tied to a spring of length L is whirled. Spring they are talking about. I think this is supposed to be string. It is not spring, string only. Is whirled in a vertical circle with the other end of the spring at the center. At a certain instant of time, the stone is at its lowest position and has a speed u. The magnitude of change in its velocity as the position where as it reaches to the position where the string is horizontal. So yeah, here it is actually string only. Alright, so now here you need to be careful. Students have done some mistake on it. They were asking about change in its velocity, and the students were calculating change in speed. They have asked change in velocity, and in fact they asked magnitude of change in velocity also. It's very clear. So you need to do vectorial difference here. Alright. So initially the particle is at the bottommost point, right? Where is it located? At the bottommost point. Yeah. Let's say u velocity. And after some time the string becomes horizontal. Let's say then velocity is v. They are talking about change in velocity vector. So v is like this. Minus u will be reversed there. V initial equal to, let us say, ui cap. V final will be vj cap. Alright. Change in velocity meaning v final minus v initial. So delta v bar, that will be vj cap minus ui cap. and that is root over v square plus u square if you take the magnitude. That is what they are asking about. Okay, so that is one point. Once we understand that, now how do you convert v in terms of u? The relation between them is conservation of energy. I think you should know it. If the height is h, right, v square equal to u square minus 2gh. So this should come very standard. Regularly we use it. Loss in kinetic energy equal to gain in potential energy. Using this idea, you will get it. U square minus 2gh. If I substitute there, what do I get then? So delta V magnitude equal to root over u square minus 2gh plus u square. So 2 times of u square minus 2gh. U square minus gh. That means x equal to 2. So the trick here is not change in speed, they're talking about change in velocity. You got to be a bit careful there, otherwise it's a very standard problem. Okay, then next. A small bob tied at one end of the string of length 1 meter is describing a vertical circle, so that the maximum and minimum tension in the string are in the ratio 5:1. Velocity of the bob at the highest position is, okay. See, I'll give you one important result in vertical circular motion, so better you remember it. Suppose in a vertical circular motion, because of gravity and tension in the string, it is going like this. Let's assume that initially it is here. Alright, V initially is like this. Tension is Ti. And after some time it has gone here. Alright, there the tension is Tf. And velocity is V final. If I know the height difference between them, let's say height difference between them is h, or otherwise delta h, let us say. Then I can directly write the relation between Ti and Tf. Ti minus Tf will be equal to 3 mg into delta h you will get. Okay, you can take this as a formula. You can get it from centripetal acceleration idea and then conservation of energy, but useful there. So now they are talking about the highest point and lowest point, right? Minimum tension and maximum tension. Minimum tension will be at the highest point. Okay, that is T minimum. Maximum tension will be at the lowest point. That's where you will have T maximum. Then delta H will be 2R. And delta H will be 2R, diameter. 2R, otherwise 12. Okay. And L equal to 1 meter they gave, that is 2. Very good. Now they said that the ratio of the tensions. Okay. So T max by T minimum equal to 5. That is given. This is what they had given. Now from this equation I can get one more relation. What is that? T max minus T minimum equal to 3 into mg into delta H. Delta H is 2. 6 mg. 6 mg. So this is the second equation, you have it. Now you got two equations to find two unknowns. We can find the tension. Alright. So T max equal to 5T minimum if I write. 5T minimum minus T minimum. 4T minimum equal to 6 mg. So I'll get T minimum equal to 6 mg divided by 4. That is 3/2 mg. That is the minimum tension I'm having it. So once we have the tension, we can write centripetal acceleration, right? Centripetal force here, T minimum and mg, both of them are there. So T minimum plus mg equals to m into v square by L. Alright. I need v there. V will be equal to root over. Mass they had given. Mass is given. Mass will get cancelled out anyway. So 3/2 mg by 2 will be 3/2 g. 3/2 g plus g. So 5/2 g you will have it. And that will be root over 5/2 into g. That will be 5 meter per second. Okay. So the rest of the simplification you can focus on. But remember this result. Between any 2 points in the vertical circle, if I know the height difference, T initial minus T final equal to 3 mg delta H. You remember it, and this information they had given. Solving these two equations to find two unknowns, you can solve it. I think that is all. Alright, next problem. A particle of mass m moves in a circular orbit under the central potential energy field, which is minus c by r, positive constant. Then the correct radius velocity graph is. Graph I have not mentioned, we can draw it, not a problem. So we got potential energy. We know that force will be equal to minus du by dr. Alright, minus of minus plus c into what is 1 by r differentiation minus 1 by r square. 1 by differentiation is minus 1 by r square. That should be equal to centripetal force. This is centripetal force. And you see it is negative meaning towards the center, positive meaning radially outward. So this should be equal to minus of m into, they're talking about velocity, no? V square by r, centripetal acceleration. That minus indicates that it is radially inward. So that minus gone and when r gets cancelled, then you will see that V squared equal to C by m r proportional to 1 by r. Otherwise, V proportional to 1 by root r. This is the graph I am having. Okay. Now, as r tends to infinity, V tends to 0. As r tends to 0, V tends to infinity. So the graph would be something like this. It's a monotonous function. It will be something like this. Alright. But it is not rectangular hyperbola. As r increases, V decreases continuously. That's what we have. And a very simple idea. Let's go on to the next problem. A constant power delivering machine has towed a box which was initially at rest along a horizontal straight line. The distance moved by the box in time t is proportional. You see that constant power idea again and again they are asking. See, if they given power, right, I can calculate work that is equal to power into time. Because it is constant power, just directly multiply with time interval. And that is equal to change in kinetic energy, half mv square, because initial velocity is 0. So from there I will get V equal to 2p by m into t under root. And that you write as dx by dt and integrate. So what do I have here? Root 2p by m constant, because p is also constant given, into root t dt equal to dx, integrate it. So root 2p by m into root t, integration is t power 3 by 2 by 3 by 2. So 2 by 3 times of t power 3 by 2, that is going to be the distance covered, assuming it is a 1D motion we have. That's the answer we have. So very straightforward. Next problem. Yeah, so this is a somewhat theoretical. So try to look at it. Given below is a plot of potential energy versus x graph, in which the particle is in one-dimensional motion while a conservative force f of x acts on it. Suppose a mechanical energy of the particle is 8 joule. I am giving a particle, I am just introducing a particle whose energy is 8 joule. So this 8 joule, whatever you have, right, that is the total mechanical energy, and that is equal to kinetic energy plus potential energy. Alright. So if I want kinetic energy at any point, that will be equal to 8 joule minus potential energy. So potential energy you can take from graph and substitute here to find kinetic energy. Now what are the options? You check it. At x greater than 4, x4, x greater than x4 meaning here, if I take over here, what is potential energy there? 6, no? If potential energy is 6, then kinetic energy will be 2 joule. But at x greater than x4, Ke is constant throughout the region, correct? And the value is 2. You see slope 0 there. Slope of u versus x graph 0 meaning force is 0 there. Force 0 meaning acceleration is not there, speed constant. Okay. At x less than x1, below this, here if you consider, here also force is not there. But at this point potential energy is 8 joule. Potential energy is 0, 8 joule, and total energy is also 8 joule, meaning kinetic energy is 0. For x less than x0, kinetic energy is smallest and the particle is moving. Particle is not moving. Particle is at rest there. So this should be incorrect statement. Let's move on further. At x equal to x2, that's where potential energy is 0. Maximum kinetic energy you will have because potential energy is least there. So at x equal to x2, Ke is greatest and the particle is moving at the highest. Okay, that is correct. At x equal to x3, you have a local maximum. Ke equal to 4 joule because potential energy is 4 joule and Ke is 4 joule, and at that point force will be 0 because slope is 0 there. So it's an equilibrium. This is stable equilibrium. This is unstable equilibrium. This is stable equilibrium. Okay. So if you oscillate it slightly, it will oscillate here. But if you disturb it, it will fall off. But you have given a lot of energy, 8 joules of energy. So if you throw it here, it will go on and run away. And finally, after going beyond x4, still it will have some energy, which is 2 joule there. Okay, that's a problem we have. Simple problem, but slightly different from what we have discussed already. Yeah, so this is some spring gun, they said, toy gun. In a spring gun having a spring constant 100 Newton per meter, a small ball B of mass 100 gram is put in its barrel as shown. By compressing the spring through 0.05 meters. There should be a box placed at a distance D on the ground so that the ball falls on it. So you need to keep a box over here so that it comes out and parabolically it will fall on this box there. So they are asking what is this distance? This is D they are talking about. Okay, on the ground, so that the ball falls on it. If the ball leaves the ground and horizontally at the height of 2 meters, this height, in fact this is supposed to be height 2 meters, this is 2 meters, then the value of D is they are asking. Okay, so these kind of questions are very common. You have to use conservation of energy to find velocity, and from conservation of energy you will move into kinematics of a horizontal projectile, right? It's a very simple idea. So imagine here the velocity is u, and that will continue to be u throughout the motion. All right, in the parabolic motion, right, projectile motion, horizontally velocity will remain constant. That u I want to calculate, and what is u? To find the u, we'll use conservation of mechanical energy. So conservation of mechanical energy says that there is a loss in strain energy, half k into x naught square must be equal to half m into u square at the time of releasing. So half cancel out, you will get u equal to root over k by m into x naught. So that is the velocity, you will have it. If you want, you can substitute the values. K is 100 and m is how much? 0.1 into x naught. X naught is how much? 5 by 100. Yeah, so this is 1000, no? 1000 under root meaning 10 root 10. So 10 gets cancelled out. You will get 5 root 10 by 10. This is going to be u there. Okay. That means how much do you have? Root 10 by 2 meter per second. That is the velocity with which it is projected. Then how much is the time of flight? What is the time of flight? You should know that is root 2 h by g. Alright, root 2 h by g. Time of flight is root 2 h by g. If you drop it from a height h, what is the time taken to come down? It is same as projecting horizontally. Even if you project it horizontally, initial vertical velocity is 0. So root 2 h by g is the time of flight. Time we can calculate root over 2 into h they are given to divided by g. So you will get 2 by root 10. So you have horizontal velocity and time interval. Then d equal to horizontal velocity into time interval. Horizontal velocity is root 10 by 2 and this is 2 by root 10. You are getting 1 meter. Right? So horizontal displacement equal to horizontal velocity into time interval. Very important conceptual question in projectile motion. Horizontally velocity will remain constant. Okay, right. That's about this problem. Next, I think we are done with this for this particular part. Okay, with that I'll conclude here. Thank you very much. These are the questions we have taken from work power energy. So I'd be very happy to explain anything that you require. So I would, if you have any comments to discuss, you can put it in the chat box there. I'll be very happy to discuss. So with that I'll conclude. See you tomorrow with the next session there. Thank you very much.